Hello, everyone. I'm going to explain the module 3 of engineering science and 2. It's called energy and momentum. The important terms is the definition of energy, potential energy, or the forms of energy that we're going to deal with in this chapter. Energy is defined as the ability to do work. And the SI unit is a joule. It is measured in joules. Two forms of energy, namely potential energy, and the symbol used to calculate potential energy is EP. It is defined as the energy a body has by virtue of its position. So this is the energy of mass and height. The formula used to calculate potential energy is EP equal to mgh. Number 3, kinetic energy. The symbol used to calculate kinetic energy is EK, and it is defined as the energy a body has by virtue of its motion. So it's the energy of mass and velocity. It's the energy in motion. The formula used to calculate kinetic energy is EK equal to half mv squared. Now, these symbols that are used here, the m is the mass of the object in kilograms. If it is not given in kilograms, you must first convert it to kilograms. I'm going to send a video on conversion of SI prefixes. G is the gravitational acceleration in meters per second squared, and it is 9.8 meters per second squared on Earth. H is the height in meters, and v is the velocity in meters per second. So if the height is not given in meters, you change it to meters. If velocity, when you want to calculate kinetic energy, is not given in meters per second squared, you first convert it to meters per second squared. Now, law of conservation of energy. Let's look at this picture, the first picture here. There is an object that is resting on top of a platform. And on top of this platform, since the object is stationary, the kinetic energy will be zero, because when velocity is zero, an object has no kinetic energy. When you substitute on that formula of half mv squared and you substitute v as zero, the kinetic energy will be zero. But the potential energy, by virtue of this height, it will be maximum. So it has potential energy. Now, if it is allowed or pushed to fall down, the height will be decreasing, meaning that it is losing some of its potential that it has on top. But that energy is not lost. Since when it falls, it will pick up some speed. That energy is converted to another form, which is called kinetic energy. So this leads us to a law of conservation of energy, which states that energy cannot be created nor destroyed. It can only be changed from one form to another. So a loss in potential will be the gain in kinetic. As it is approaching the ground, it's losing potential, and the kinetic, that energy is transferred into kinetic because the speed is increasing as it approaches the ground. Now, before it hits the ground, the potential, all of the potential will be transferred or will be lost. And the kinetic energy will be increasing, and it will be maximum before it hits the ground. That is the law of conservation of energy. Velocity and distance at any stage. So one of the things we're going to calculate on this chapter will be the velocity or the height at any stage. So when the object is falling down, if a question says calculate a velocity, let's say if the initial height was 10 meters, now the object says, or the question says, calculate the velocity when it has fallen 2 meters. Now the formula to calculate that velocity at any stage is v equal to square root 2gs. And this s is the h, or is the height. It is the distance that is covered by the object. If it's going down, it will be this distance that is covered by the object. But look at the picture on the right-hand side. The object now is projected vertical upwards. You still use the same formula, but if it's going up, the S or the H there will be the distance covered from the bottom because it's projected upwards. But if it's falling down, the S or the H you're gonna use there will be the distance covered from the top. So please take note, S or H that will be there will be the distance covered by the object. If it's going down, it will be the distance from the top. If it's going up, it will be the distance from the bottom. So you calculate velocity at any stage. The formula that I used here is EP for potential energy mgh. I already explained what each symbol represents. EK half mv squared. But since this object will be in motion, you can also use the equations of motion. These are the equations of motion, and it's a falling object or it's a vertical movement. It will be V equal to U plus GT. Now, when it comes to equations of motion, you need to remember if it's going up, G is negative 9.8, and the V at maximum height will be 0. But if the object is going down, when it is going down, the velocity, which is initial velocity, will be 0, and the final velocity won't be 0. Gravitational acceleration will be positive 9,8. Then these equations of motion can be used to calculate. You can calculate time, you can calculate velocity, but take note that the sign of G going up is negative, going down is positive when using equations of motion. But if you're going to use potential energy formula, G stays positive because this is the weight is acting down, mg is weight. Now, this formula of calculating velocity at any stage, it is coming from equating potential. Loss in potential is a gain in kinetic and vice versa. So if under potential, you put the equation of potential mgh, it will be equal to half mv squared, which is the formula of kinetic energy. If you divide throughout by m cancels out, and cross multiply, this will be 2gh equal to v squared. Then you put it under square root both sides. It will you'll end up getting this formula. So where there is s, you can also put the height. Okay, so you can be able to do the calculations or the activities under energy. Now let's look at another concept called momentum. Momentum of an object is the product of its mass and velocity. The symbol that is used to calculate momentum is capital letter P. It's a product, so you multiply the mass of the object and its velocity is m multiplied by v. And this m is the mass in kilograms. If it's not given in kilograms, you convert it to kilograms. And v is the velocity in meters per second. conversion if it's given in kilometers per hour or meters per minute. Now, when you put these two units together, they will give us the SI unit of a momentum, which will be kg dot meter per second. Now, we can have a case where you calculate momentum between the objects that collides. Momentum before collision, we're going to use the initial velocity, which will be P before m multiplied by u for initial velocity. But momentum after, we use the final velocity. It will be P after equal to m multiplied by v. You can also calculate the change in momentum. The symbol to denote the change in momentum is delta P. Delta P will be equal to P after minus P before. And the symbolical expression will be delta P equal to after is a final, has something to do with final velocity. So it will be m multiplied by v, which is final momentum, minus m multiplied by u, which is the initial momentum. So another names that can be used for a change in momentum, it can be called an increase in momentum. If a question is increasing its velocity, so it also momentum is increasing because velocity is increasing. So it can also be called an increase in momentum. If a momentum is losing or is decreasing a velocity, it can be called a decrease in momentum. It's still change in P, the symbol. Or it can be called a rise in momentum. So all these terms are referring to a change in momentum. Conversion, what gives you a momentum is a kilogram and meter per second. Now, momentum is just a technical term of something we already know. If a train and a car are going in the same direction at the same speed, of which the two will be easier to stop. So you can answer this question. If the speed is the same, is the train and the car. So the train is heavier. It will have more momentum because its mass will be bigger than a car. The greater mass of the train gives it more momentum. Or you can also compare a bullet fired from a gun and a bullet thrown by the hand. Which one will have more momentum? Momentum depends on two things, the mass of the object and the velocity of the object. So when increasing the momentum, you can increase the speed or you can increase the mass of the object. Even though they both have the same mass, the bullet fired from a gun will have more momentum power due to its higher velocity. Okay, I've already covered this part, momentum, the symbol used, increase, decrease, rise, or change in momentum. NB, the velocity or initial velocity is always positive. However, if an object bounces back to an opposite direction, the final velocity V will be negative. So when object bounces back, and you're gonna use the formula delta P to calculate the change. But since it bounces back opposite direction, this one will be negative. And formula for a change is a difference between the two. Then you subtract the mu, which is the initial momentum. And the last one, initial velocity is always positive. However, if an object bounces back to an opposite direction, the final velocity will be negative. And that's all.